Well, good afternoon, everybody, and welcome to the launch of Curve. We have a lot of participants today. That's a wonderful thing, and I've unmuted Don as well. You there, Don?
I'm here. Can you hear me?
I can indeed. I can indeed. My name is Steve Upton. I'm the president of CHROMiX. We also have Don Hutcheson, the inventor of G7, and we will be co-presenting this. I will give basically the first half of it. Don will give the second half, and we'll be chiming in on each other's halves as we move along. Curve4 has been a long evolution in coming. We started out with Ideal Link Curve under ID Alliance, and we've been moving our way up progressively, and now we're at this fourth major release. And we've been working on this release, it turns out, for about 2 years now, which is kind of stunning. And we're very happy to be bringing it to you now. We've modified how the user interface works. Most of the people on this call are going to be existing Curve 3 or 2 or 1 users. So we're going to try and put things in perspective relative to that. Curve 3's user interface was basically that there was a single document window, and in that window was what we called a session, which could have multiple press runs in it. And it had a number of other tools available. It had the ability to verify. You could do VPR, so you could curve measurements as if they had gone through another press run. The window represented a session. And contrary to popular belief, the verifications themselves, the measurements, weren't actually saved. So when Ideal Alliance brought out the 2015 G7 Master Certification document, which documented very clearly what the tolerances and metrics were, we knew we wanted to integrate that well into Curve4. So we promoted the Verify tool up to its own tool. And we renamed the main function the Calibrate tool. And then we added a new tool called Blend. And these tools are available with various levels of licensing from Verify on up. Okay? When it comes to the Verify tool, what we wanted to do was make a tool that was easy to use and very clear in what it did. The idea was to make it very easy to bring measurements of some sort into the software and give very clear results. So I'm going to click on the plus button here, and I can bring up, well, let's say a P2Ps versus the measurements. So you can see here that we've got a very graphical interface of what's been summarized here. Each one of these colored fields is one of the parameters, one of the metrics that's used for G7 verification. There are also 3 separate levels now. Grayscale, which is just the gray ramps for black and for CMY. Targeted, which includes, of course, the grayscale, but also the specific color solids from a print process. And then Colorspace, which includes an entire IT8's worth of color targets. And what Curve4 will now do is actually, and I'm going to bring up, let's see if I can. I have a P2P that I brought in here. And it doesn't have enough patches to actually give me full color space verification. I need a full IT8. But a full IT8 doesn't have all the patches we need in the gray ramp. So the Verify tool will actually automatically combine measurements that you bring in. So I brought a P2P51 in. Now let's bring in a full IT8 in addition. It automatically averages the duplicate patches and combines everything together here. And you can see now I have the full IT8's worth of patches. And now it tells me, unequivocally that it's failing. That's okay. It's a really horrible inkjet. Now you can see the full information. So if I make another verification, in this case I will drag in a much better behaved IT8 for Grayscale. And you will see how it's missing patches in the gray, and so the grayscale level fails. Subsequently, Targeted and Colorspace also fail because they rely on the others in order to pass. But if I bring in a P2P for Grayscale, it'll fill in those extra patches. Now what's been put together here is that Ideal Alliance, I think it was Don Hutcheson and Bruce Bain, to basically put together the full gray ramps from the P2P and a full IT8 into a single target called the TC1617. And if you're doing color space level verification, that's the one to use. So when I want to do a verification, I just drag a TC1617 in here. Let's say it's the Grayscale one or whatever. And there we go. From one target, we get all the information we need, but you can see Curve is very flexible in allowing you to drag all kinds of different data sets in there, and it'll pull out the patches it needs, averages any duplicates, etc. What I wanted to do was kind of give you a quick overview of how the window works, and we'll go from here. I'll do the Verify tool, and I'll do some stuff on the measurement side of it. The single most requested feature we had was integrating measurement into the software. And so we've done that in spades. We're very happy with what we have, and I'll be showing you that as well. So this window is a general purpose window. I can open up a new window at any time and see the same list of verifications if I want. It's kind of a browser type window, if you will, where I can browse the data. I can flip to the Calibrate tool and look at different calibrations that may be in here. I can flip to the Blend tool, etc. So the window gives us a lot more flexibility, and then you just move between tools, Verify, Calibrate, and Blend. And there's a quick key, Command 1, 2, and 3, or Control 1, 2, 3 on the Windows side to move between those. But they are now, as I mentioned, full-blown tools. They have their own document types. So when I say I want a new verification, obviously I click the New button. I've been doing that. And the verifications are automatically named and automatically saved here on the left side. This is basically the file handling function. Don's calling it the work list in the documentation. And each of the tools has it. Now the verifications one, the documents are automatically named and dated and reverse sorted, so the most recent one's at the top. And this allows you to set up a customer, for instance, really quickly and easily. They just click New, measure or load verification information, and off they go. If people have a Maxwell account, you can click the little Maxwell icon here, and it will open up and show basically all of the information that a Maxwell user might have online. And they can drill into a track, find a particular measurement that one of their devices took into Maxwell, select it, say OK, and it will be downloaded automatically from Maxwell. You can also upload resulting blends into Maxwell and use them as color aims if you want. So this kind of interaction is meant to be as streamlined and simple as possible. Now, one of the important parts of verifications is the reference that's in use. And Curve comes set up with a handful of them. I have a few more in here than, in fact, that come with it. But you can just say edit or add references. And in this window that opens, you can create any kind of reference. So you can set the level of G7 testing that you want. So if you don't want to go for full color space, you just want to do grayscale or whatever, you can set that. You can set the color aim. It has all the CGATS level, XCMYK built in. If you want to create your own color aims, you can do that. It's a sort of a multi-step process because we first verify in the Verify tool that your data is G7 compliant. And then you save that explicitly by pulling down the file menu here and saying save as color aim. And then it will appear under here and you can select it as a color aim. But you can select the SCCA settings, etc. in here. Give your reference a meaningful name, and if you want, one of them can be set as the default. This one, Grackle 2013, is set as the default. Once that's set up, again, a less experienced or a very busy user can simply click New, and it automatically selects the reference. They bring in a set of measurements, they get a quick verification, and they're done. You can print a report from this as well. It's a full-page report that's available. But as mentioned, we have integrated measurement into this. So what I wanted to do was bring that in on the fun. There's some live video here of a Barbieri Spectral LFP that we can drive. And so there's a variety of different hardware that you can drive directly from Curve. I1 Pro, IO, and ISIS, and the Exact is coming soon. And so we'll be direct driving the Exact, as well as the Spectre LFP, Konica Minolta's FD-9, and the Techkon Spectrodens. All great instruments, all different traits and capabilities, so we really like to be able to support different types of instruments. Now, a lot of this measuring capability is inherited from Maxwell. So a lot of the workflow and the setup and the functionality we have here has been field tested by our Maxwell customers for years. We're pretty proud of the way it's turned out. There's some controls here on the bottom that make it sort of easy and as obvious as we can to basically set the different M levels for filtration. It depends a lot on the type of instrument, of course, but we can do transmissive type measurements for this instrument, different kinds of control, different aperture control. It all depends on the kind of instrument you have. And all of that data is recorded with the measurement. So I wanted to show the LFP at work here. What we've done is we've taken advantage of everything the instrument can do. So a Barbieri LFP can do automatic detection of where the target is on the page and that sort of stuff. But we wanted to go farther than that. And so we've introduced this memory scan capability. And memory scan is available on the Barbieri LFP as well as the IO, and also to some extent on the FD-9 from Konica Minolta. What it allows is if you are able to position your target in the same position on the table, which isn't particularly difficult to do in most cases, then you can set the memory. So I'm going to do that right now. So I can move this around with my arrow keys and position it. Imagine I'm doing a measurement of this particular proof here. And it's on the sheet with a bunch of other elements, but I want to be able to get this particular target off it. So I do the positioning. It gives a chug and it's done. Now that's just been saved in memory. So as long as I can position that target on the table in the same position, I just need to open up this dialog and click start, and it will find it in the same position on the page every time. First, this particular instrument cannot change the filter or even know what filter is in place. So we make sure that we double check with the user that it's the right filters in place. If you've ever done a bunch of table measurements with an IO or with an LFP, page after page after page or day after day after day, you will realize how wonderful this capability is. And of course, the Barbieri is an interesting instrument. Sometimes it actually benefits from just being power cycled. Sometimes get itself in that position. But I have another instrument we can use as well for demo, which is the FD-9. Once it gets running, the great thing about this particular memory scan function is that it can just find the target on the page the same way every time. And it should actually save us time this time as well, because we don't have to position it again. And we figure you could probably pay the cost of an IO in a month or two if you do a fair number of measurements. So try this measurement here. While that is running, I wanted to mention the Verify tool can also open ICC profiles. So if you have a profile that you're wondering if it's documenting a G7 capable system, you can drop the profile right into the Verify window as if it were a measurement, and it will automatically be translated to a TC1617 and verified. You can also save that as a color aim, and so any profile you have on hand can be converted into a color aim to use for that kind of verification. Okay, there we go. Now you'll see there's some chunks missing here. That's because this tiny little target doesn't actually have all the patches that we're hoping for here. But we're going to leave the Barbieri behind and move on to the FD-9. So we wanted to show the FD-9 today because it's a great instrument. We've had some great luck using it, and lots of people haven't had a chance to actually use it yet. So yeah, there we are. So the FD-9, it looks like a printer somewhat, same sort of form factor as the X-Rite Isis, which we're also a fan of. It really doesn't like its door opened when it's in the middle of measuring, but you can open up the door and check it out inside. Let's do a measurement with it here. I'm going to say new, and I'm going to measure, but in this case, I'm going to just give it a sec to talk to USB. Still wants to talk to the LFP. Okay, so let's select one of these 2-row targets. And you can see on the camera here that this is the same kind of print. It has a target at the bottom of it. Now that target's at the very bottom of the page, and the Konica Minolta, the FD-9, does not like targets at the very bottom. It needs a bit of margin. We've made things so it's easy to just flip it around upside down. And in fact, this target was already rotated, but you can use these rotation buttons in case it's not in the right position for how you're choosing to scan it. And you can scan with an i1 Pro upside down from the bottom up, like Fogger recommends happens. So there's a fair amount of flexibility in how things are measured. But basically, I can just fire this in. And I've said manual positioning here. First thing it does is it scans the page in, spits it out, and it's done an entire grayscale scan of this. There we go. And you can see what was scanned. Okay. I can just click and drag where the target exists on the page. I can click confirm if I'm worried that it might not find the patches. It'll put little red dots over each patch to confirm that that's where we want. Yep, there we go. And then I say measure. And I can have this in any rotation. I can do whatever, and it is fast. It'll do M0, M1, and M2 type measurements, and that's that. Bang. So another one that I have in here, just to give a demo of how quickly this thing can go, is a P2P, but I'm just going to measure half the P2P because I just want to do a verification. I don't need all those gray rows. And what I'm going to do is rotate it so I can put it in sideways, like that. You can see on the video, I'm going to put it in fat side, and that just makes it that much faster. We'll pull it in. Now, memory scan is available on this type of instrument as well. So if the target is on the same position on the page, like that earlier one, every time, I can just select it. Let's see, let's do a click drag. I don't have to even confirm in this. I just say measure. It should do it. Yeah. And I do a quick measure of part of the target that gives me basically the G7 grayscale and the targeted number of patches that I need. I don't need all those other gray bars because I'm not doing a calibration at this particular stage. And that's that for that. The idea behind this verify tool, as I mentioned, is that it's quick and easy and, fast. There is, for those with the Calibrate and above license, there's also sort of a what-if function. If you roll over this badge, you can click the plus sign, and then you can actually fiddle with the parameters of the reference. So you don't have to necessarily go into the reference area and make a new one and all that sort of stuff. So if I want to bring this back to just say targeted level, it'll say, well, you wouldn't have passed that because, but listen, what if we do SCCA? And you can fiddle around with this. You can see the reference is flipped to custom because you're monkeying around with it. But if you want, you can also save that as a new reference and go from there. The file management stuff in the left side here, again, you can make folders for these types of things. You can make folders in here. You just click the plus down button down below and make a new folder. And these are all represented by files on the disk. So if I right-click any one of these, I can say Show in Finder. I can rename it. I can even click at the top of any one of these on the name and rename it. So you can move around and change things pretty easily. But you can also drag them into folders, and you can make folders for your customers. So if you go from plant to plant or customer to customer, and you'd like to have all your work organized, but you don't necessarily want everybody seeing everybody else, you can make a folder for a customer and then just double-click on the folder, and it hoists that folder up. And you go into that folder, you can do all the work for that particular customer, and then when you're done with that customer, you can go back out to the top level and go into another customer or a different test or a different plant or whatever. So the idea is that it keeps your work organized easily, and you can use that in all three of the tools. So I'm going to hand over to Don now.
Excellent. Hi, everybody. Thanks, Steve. Steve's done a nice job of looking at the Verify tool, which I hope you'll find really cool. I'm going to talk mostly now about the Calibrate White tool. So Calibrate is, of course, the meat and potatoes of the Curve4 software. And we've tried to bring a lot of new features in while at the same time keeping it as friendly and as familiar looking as possible. So, of course, the basic diagram looks a little bit different. What Steve didn't show you was one of these cool things, that little work list on the left can actually be scaled. You can even hide it by double-clicking it, and then hopefully make it reappear by re-clicking. Yes, it reappeared rather nicely. And I also have a series of folders right now. I'm working off the folder called WebEx. So let's go back in there. So let's start off by making a new calibration. If I click on New Calibration, it defaults to whatever you'd used last. Right now we'd use G7. As you can see from the top here, we can calibrate G7, calibrate TVI, and we can calibrate with a new SCTV. Before I get to SCTV, let me just briefly show you what you can do in TVI. It's a little bit different from before. We have preloaded all of the 1994 curves, A through F, and also now the 2013 curves, A, B, C, D, and E. And you can also load your own custom curves if you want to. I'm not going to do that right now, but there's a way of loading your own curves. So we brought it right up to date with the latest ISO 12647-2 2013. Probably the cool new addition is SCTV. I will get back to G7, of course, but SCTV, if you haven't heard of it, is a new method of calibrating for spot colors that is now an ISO standard. It's ISO 20654:2017, measurement and calculation of spot color tone value. So spot color tone value is SCTV. What's cool about it is that if we calibrate to SCTV, we're going to get very, very evenly spaced steps in any ink at all, ink of any color. Some really cool research went into this and came up with this formula. It can be applied to absolutely any spot color ink you like, and it's now a standard, and it's recommended for everyone who's printing spot color, including people who are doing 7-color process or mostly just spot color. So let me just have a quick look at it. In SCTV, I'm going to load briefly a bit of data. I've got some already loaded, so SCTV. Here is just a raw SCTV target. When it loads, right now you don't see anything very useful in the NPDC curves because there's no such a thing as NPDC or gray balance. We're working on this window, and later in this year we're going to have a slightly more informative view here, but it really doesn't matter because everything's all about create curves. If you go straight into create curves, let's pick 25 steps. It's immediately telling us how these 4 channels, which are nominally called cyan, magenta, yellow, and black, but in fact you could have printed with any inks, how they should be corrected in order to meet the requirements for the SCTV. So let me just show you what that target looks like in Photoshop. I probably have a picture of the SCTV. Here it is. Here is the SCTVI target that we currently are giving out. And this is 25 steps of 4 inks. And you see on the top right, it says print with CMYK or any 4 spot inks. So at the moment, you know that the cyan channel is really your orange or your green or your red or whatever. So where it says CMYK here, it really means whatever colors you got. So let's just see if this thing works. If I go into VPR, Virtual Press Run, which is enabled if you buy the full complete license, but would be grayed out if you only had the Calibrate license, I can actually apply the curves I just generated to that same data. So I'm going to open that same data, which is CDI, SCTVI, and as a reference, I think it'll do it based on itself. Let's pray that it does that. I'm going to click Curve and Export, and I'll just call it SCTVI, SCTV curved, and I'll put a 2 after that. As you can see, I did a little practice earlier today just to make sure this works. So now we simply pray that this does work. I now make another calibration, and into that I will load SCTVI curved 2. I actually have all my appendages crossed right now to make sure it works. The only way to know that you've got it right is to go to Create Curves and to make sure that you don't have any suggested changes, and we don't. So this shows that the SCTVI really did work. This is the raw, and this is the corrected one. So that's cool. That's enough about SCTV. Those of you who do spot colors, I think you're going to love this. It's an extension of what we had in Curve 3. I think we called it Special Inks. TVI I've shown you. Let's now get into the meat and potatoes. Let's get into G7. So I'm going to make a new calibration. I'm going to call it G7. As you can see, nothing much has changed. This is very similar to the same user interface we had in Curve4, and that's deliberate. When something works, there's no particular reason to change it. So there are not a lot of changes. Under the hood, though, I should point out that the algorithm used in Curve4 is microscopically different from that in Curve3. We now adhere slightly more accurately to the TR015 specification, which was not out when Curve3 came out. So if I want to demonstrate, I'm going to go to some pre-made ones right now. Of course, we can use the regular P2P target. So if I was to click Measure, I could pick the regular P2P51X, which is a vertically orientated target. Most of you remember that. Or I could do the P2P51H, which is a new horizontal target. If you haven't got it or used it, again, let me show it to you real briefly in Photoshop. This is really cool. This is a lot faster. It reads in the ISIS approximately twice as fast as the old P2P target. So that's already a nice step forward. I'm not going to read because it's going to take too long. I'm just going to load some data. So I already have it loaded here. So here's the P2P51H. Now this is off some old press. I just searched for some data. It's not particularly perfect press. You can see that the shadow end, it's a little, got a warm cast. CMY looks good, and NPDC black is a little heavy. Another little cool thing I want to show you, though, is that we don't have to measure the full P2P51. That's 300 patches. One of the new exciting things we can do is work with some smaller targets. So you see, here's the P2P51. That's 300 patches. Here, from the same data, I've actually loaded a micro P2P. It's 96 patches, and it produces almost identical results to the 300 patch. In fact, we have two versions because I love playing around with things, and I wasn't sure which one would be best. Here's the mini P2P, which is 125 patches. Here's the micro P2P, which is literally 96 patches. And if you look at the graphs that I'm displaying here, as I toggle between micro and mini and the P2P51, they're almost exactly the same. So going down to less than a third of the patches, we get very similar curves. Here's the full P2P51. If I go to the micro P2P and look at the curves, you'll see that the correction curves are virtually exactly the same. And this is going to save you a lot of time and save you a lot of real estate. So a lot of people are excited by this because calibration will be quicker, and or you'll be able to save or measure more targets at once and get better results. In these examples, I'm just throwing one target in here. Naturally, of course, we can average as many targets as we like. The software does that automatically for you. So that's very cool. One other feature you get before we go to the features we enable with the higher licensing level, if I go back into setup, something you might have seen here is ink restriction. And ink restriction is done specifically for our inkjet users. Every inkjet rip has some method of ink restriction or ink limiting, and they all work reasonably well, but determining what the ink restriction settings should be can be a bit of a nightmare. So we've thrown our hat into the ring saying, here's a tool which we hope you will find somewhat useful. So here is what it looks like. If I drop in a set of data, and this was printed with just a regular P2P target, ink restriction, there you go. This is just an ordinary P2P. It will work with more elaborate targets. We can throw all sorts of different targets in, but it's surprising how well it works on the P2P. We're seeing here a graph of the CMY curves on the left, the RGB curves on the right, and the NPDC curves on the right. Now, depending on the condition of your printing system, any one of those three sets of data may have a reversal in it, or may have a situation that is indicating there's no point going beyond a certain ink level. For example, if you look at this blue curve here, it's reversing at about 80. Now, that doesn't mean to say we should stop adding cyan, but it does indicate that we may have more cyan going on than we particularly need. One of the key indicators of a well-balanced or well-set-up inkjet system is that you're getting roughly neutral results for 300%. So if I click this little button here that says Neutralize CMY, it has instantly gone in and found what the CMY percentages would be in order to produce a value that's virtually neutral. In this case, it's a value of 13L, minus 1.1A, and minus 1.5B. So that little button there immediately suggested that we set our limits to 87.7 cyan, 94.2 magenta, and 100 yellow and 100 black. And you can also see, I don't know if you saw it over here on the spider diagram, that central brown dot now has centralized. If I go to move any one of these, you'll see that I've changed the position of that brown dot. I've taken so much cyan out now that the 300% is going to be very, very dirty. So I didn't want to do that, but it shows you exactly what's going to happen. You can also see from these spider arms how the color space will react to this different level of limiting. If I take it back to that 87, which is where it was, hit neutralize, there you go. So now we've got a neutral result here. So this is really, really cool. This is a way of quickly determining what is probably going to be a good limit. Now, we can suggest that you apply that in the RIP. If your RIP just takes these numbers directly, you'd go off to the RIP and do it. Or we can say, we'll apply that in curves. And there are one or two RIPs that don't allow you to do ink limiting. If you have such a RIP, you would apply the ink limiting in curves. So now if I go to calibration, you'll see I've loaded that. It's exactly the same file. You look at these graphs, they're actually stopping at less than 100. So you can see now the wanted value for 100 in cyan is down to 86%, 92 for magenta, 97.76 for yellow, and so on. And this you can now export, and you can actually apply it as a curve. So for those of you who are doing ink limiting, hopefully this will at least help you determine the right number, and perhaps in some cases even allow you to apply that ink limiting, for example, in Photoshop or in a RIP that doesn't allow ink limiting. So that takes us to the end of the features you get in Calibrate without purchasing the additional licensing level. If we now say that you've got Calibrate, but you actually purchase the complete version, now we have a couple of extra tools we can do. I think what I forgot to mention is you can actually work from an ICC profile. We can actually load an ICC profile as well. I believe that's, Steve, you'll have to chime in here. Is that included, or is that available only with a more expensive level?
It's included with the Calibrate level. It's included with each level of the tool.
Did we get generous or what? Okay, let's now talk about recalibration. This is really cool. Recalibration is where we work from super tiny targets to correct a press run that already had been calibrated but had drifted. So here you see my raw data, the raw G7. Here is the result of calibrating. See, we're now hitting the curves perfectly, and our gray balance is as good as possible. If we now go off and print a super teeny tiny target, what you see in this window here are 1, 2, 3, 4, 5. There's 6 of our delta recal targets, and they can be printed in a live job right down to this little one at the top, which is a 6 patch. We call it delta recal 6. 6 patches, or you can use 9 patches, or 11, or 16, or 27, up to 40 patches. Simply by printing those 6 little patches, let's see what we can do to rectify a calibration that might have drifted. So here we have a perfectly good looking calibration. If you included that little 16 patch, so let's go to the 6 patch target. If you included it on a press run and nothing happened, that nothing had drifted on the press, you're going to see curves very, very similar to what you had seen with the whole P2P target, even though it's a super tiny target of just 6 patches. More importantly, if we go into the Create Curves window, and now I'm going to use the down arrow and up arrow to look at the different curves, you'll see that here were the curves that we got after we had calibrated to G7 using the P2P 51. The 16 patch target is asking for virtually no change, and the 6 patch target is asking for virtually no change. What's cool about this is you can include that little 6 patch target on every job you do, whether it's an offset press or inkjet, it really doesn't matter. Flexo. While I'm at it, you can see a little handle I'm hovering over here. If you want to expand the list of runs, we can do it that way. Or if you want to expand the column of runs and measurements, you can do that way as well. So Delta Recal, probably one of the most valuable features that we've added to Curve since it first came out. The other cool feature we can do is we can calibrate using something other than a P2P target altogether. So let's just create a new calibration here. And in the calibration, you might have noticed this little button down here. It says Auto, or P2P, or Delta Recal, or P2P less. If I click P2P list, I don't actually have to do it. The software would recognize automatically. I could load in here something a lot more sophisticated than a P2P. For example, I could load a complete TC1617 target. That's 1617 patches. And the software will extract from it the P2P and immediately give us our suggested curves. This is really cool if you don't want to run separate targets for profiling and for calibrating. It's also cool in that here we can see there's an error. Having determined what our corrections were, let's apply our full amount of correction here, and a gray balance to the max and so on. We can now go straight to VPR right in this window and say, what is the target to be curved? Let's curve that same data. So I'm going to go to that same folder, which was CEDA TC1617, and click open. And I'm now going to curve and export, and I'll call it CEDA TC1617 G7 corrected. Click save, export. Now I can export it as a text file or as a .mxf file directly via one profiler. If I export that now, we now have the data that represents how this press run would have looked if we'd done a second press run. In other words, what you've just seen here is virtual press run, which I know some of you are familiar with from Curve4. But the cool thing now is, A, we're going out as an MXF file, and B, it's happening right there inside the Calibrate tool. So we created our curves, we created the new data. These curves would go into the press, and meanwhile, the VPR result would go straight into a profiling software. So that's pretty much the highlights, I think, of the calibration function. Let's go on to the blend tool, because I'd like to leave some time for question and answers if possible. So right in blend tool, you're immediately seeing the original function we had set blend up for. Here in blend, I've actually loaded in 1, 2, 3, 4, 5 different targets, and they're not all IT8s, but they're all done for our XCMYK project last year. So you can see some are in different arrangements and so on. And they're actually from different presses, but they were all done basically to the same targets. What we wanted to do is be able to average them, but there's more than one way to average. You can do a simple mean averaging, you can do a median averaging, or you can do a weighted averaging. And depending on which type of averaging you get, may be more suited for different types of conditions. But simply averaging that data, we now have a choice of what do we want to output from that. And we can say IT8.7/4, yeah, we could output that. And if I click on blended measurements, that's going to show us what it's going to output. Or I could say regenerate, and this is a really cool feature. Now with regenerating, I can say, turn this into a TC1617, even though we didn't print it. No, let's go further than that. Let's turn it into an HC2052 FV, whatever that is. That's a 2052 patch target. So it's cogitating now. It's actually doing a fairly sophisticated job where it's calculating the values of all the patches in the HC2052. And any minute now, when the little circle stops spinning, I'll be able to export the data. So we've got a circle there, and we've got a beach ball spinning. This is where we told war stories. Everyone have a nice weekend. Oh, there you go. So here is the HC2052. I can now export that blended file, and I'd call it probably HC2052, XCMYK average. Let's just call it that. And I'll put it somewhere up there. And MXF or text, doesn't really matter what I want to export it as. So I've now exported a blended averaged target consisting of all of the data here, which is very nice. Now, that was what we originally designed this for, but then people said, why don't we also allow remapping white? So into the bargain, regardless of how many data sets are in there, it could be a single data set or a group of them, we can also, let's say, optimize our white point. And for example, if we wanted it to be perfectly the same as Grayscale, which is 95, 1 minus 4, that's available in that little list. Or we could say, no, I want to simulate a bluer paper. Let's make it a -6, okay? And let's make it a brighter one. Let's make it 96. Ooh, we can go crazy here. We're simply doing SCCA here, if you're familiar with what SCCA is. That's substrate corrected colorimetric aims. And there is a pivot option. We can pivot it on the default pivot, or we could pivot it on the Remap Black. Now, what is Remap Black? Remap Black is very similar to SCCA, but at the other end of the scale. If I switch it on here, what Remap Black is primarily for is to compensate for the problem that when you measure uncoated stock and material and you make a proof of it, it usually looks too washed out. So the demo I was in the middle of here was demonstrating Remap Black. I'm going to change that to a new demo. And in this one, I'm going to load the actual data from Grayscale CRPC 1. Here it is. CRPC 1 is newsprint cold set. So if you look here, it's a pretty ugly, drab-looking piece of newsprint. The problem with this is if we make a proof from this, and we make that proof on glossy paper, it's going to look flat. And the reason it looks flat, I don't want to go into details. There's a whole annex in our user guide about why. The problem is that the measuring instrument typically doesn't measure enough contrast in the shadow. If I go to Remap Black, and I say the matte black on that sample was measuring, let's say, 35, but when I measured a visually similar patch on a glossy surface, it was measuring, let's say, 20. I don't know. I'm just thinking of that. I don't know if you noticed it, but in the background, the contrast just increased. Let's do disable. It's all flat, and enable. Enabling actually makes it more contrasty. If I now export that data, which I could call CRPC1 enhanced, let's say, I can now go off and make a profile with it, and let me show you what that would look like. I'm going to go back to Photoshop. What you see on the left, we have a standard image viewed in the proof setup custom settings where we have CGATS, CRPC1, preserve CMYK numbers, simulate black ink. So you see the low contrast, the flatness, supposedly, of a newspaper print. If I now open this one, the view proof setup custom, I'm using CRPC Remap Black 35 to 20, which I had just done a moment ago. If you look very carefully, hopefully you could see this across the WebEx universe. The one on the right has got more contrast. And I can tell you that, having done this experiment many times, it looks much more the way the actual uncoated paper looked than the one on the left. Even though the one on the left is made from correct measurements using 0.45 geometry, they always seem to come out flat. So if you've ever had that experience that your uncoated simulations look too low in contrast, this is the tool for you. Hopefully you're going to find this very useful. At some stage in the very, very far distant future, this may even make it into some kind of a standards level. So anyway, I've talked about averaging, regeneration, SCCA, Remap Black, exporting. The only other thing to quickly show you is, of course, we can also do VPR inside the blend tool. So if I wanted to apply a virtual press run curve to this data, I would now be able to go and load any of the curves I have currently available to me in the Calibrate section there. I'm not going to go through the process of doing it, but that's something we could do as well. And you can do that at the same time as you remap white and as you remap black. So looking at the clock, Steve, what did I miss?
There's a little verify button at the very bottom of that window. So that if you're working on some data and you want to just double check and see if after all your manipulations it might actually pass, you just click the button, it flips over to the verify tool, makes a new verification, Bob's your uncle, so to speak.
Thanks.
So that's a handy part of it, yeah. There's also, if Paula's on the line, I don't know if she is, but there's also a handful of features that we added with her in mind because some of the requests she made. And that is, if you drop a simple text file, a measurement, into the list on the left in any tool, verification, calibrate, blend, if you drop a single text file in there, it'll create a new document and put the text file in it. So if you have a text file you measured somewhere and you just want to drop it on, bang, it'll work. But what you can also do for the verification tool is you can have a folder full of files and drop it on there while holding the option key. it will create a folder of verifications and a new verification per file. So you can check a whole bunch of different files side by side against each other and see which ones may or may not have passed. Go ahead, Don.
What we didn't show was the reporting. Let's have a quick look. I'm just going to save a verification report and just call it Untitled. And then I'm going to open that. So we have a whole bunch of new reports, which hopefully you'll find a little bit more useful. So this is a verification report. We also have calibration reports. So that's what a verification report looks like, and this is what a calibration report looks like. And you'll be able to basically file these, leave them with your client, and so on.
The licensing for Curve4 works in 3 levels, 4 if you include demo. The Verify license turns on the Verify tool, no big surprise. The Calibrate level of license turns on the Verify tool and most of the functions of the Calibrate tool. And then finally there's a complete level of license, and we call it that because not only does it turn on the Blend tool, but it turns on a number of the enhanced features like VPR, P2P-less, and Delta Recal abilities in the Calibrate tool. So there's 3 levels, and there's upgrades from pretty much any version of Curve that you had before. If it's not available on our website, then by all means give Rick a call in sales, and we will figure out a way of doing it. And also, I want to give kudos to all the instrument manufacturers. There's 4 different manufacturers that we work with, and every single one of them stepped up to the plate and offered a 90-day bundle deal. So any, I think, of the instruments that we drive are available as part of a bundle. We're very happy that we're able to do that as well.
Okay.
There's a question. Is there a timeline for the interface to the Exact? There is a timeline for the Exact. What I've been telling a few customers is that we will have it working by the end of June. But we have actually made some pretty rapid progress, so it might happen sooner than that. Supporting a piece of hardware like that has its foibles. You never know when you're going to fall into a pit, spend a week thumping around. But it's actually going quite well. And judging by what we've seen so far, we should be able to support it both via direct connect USB as well as the Bluetooth connection. The extra targets we will be including in a folder with the build of the app. The current build does not have that kind of sidecar folder of targets, but we'll be fixing a few little things we found along the way and doing a new release likely on Friday of this week, and we will have the folder of extra targets included with that as well, the new P2P Mini and Micro and whatnot. There's a question about the smoothing feature. The smoothing feature available in the Calibrate tool is something that you can check on if you want, and it does a multi-dimensional smoothing function. It's the same sort of function that actually works in the regenerate function under Blend. What it does is it throws all of your data into a bin, and then it looks up the data that it needs. And by doing that, it does a full multi-dimensional lookup. So each patch kind of affects its neighbor, and the net effect is it becomes much smoother at just smoothing the raw data itself, which can be very handy. We always recommend when you're doing a G7 calibration that you measure as many targets as you can, to some reasonable level. But more than one target is a good idea. It tends to smooth out measurement errors and also print problems like pimples or things that might appear on patches. But smoothing works on top of that and even makes the data more smoothing from there. Is linearization available in the plain Calibrate license? Yes, it is. Linearization does not require the complete license, just a Calibrate level. You see the Maxwell logo in the UI, is it fully functioning for upload and download to the cloud? Yes. So in any one of these, Don hasn't set up his user ID there as he's demoing, but with any one of the windows that takes measurements, so all 3 of the tools, including the ink restriction tool, if you click on the Maxwell icon, you can explore all the data up in your Maxwell data set. We're at about 210 million measurements in the system right now. And it'll automatically download and drop them right into the Curve tool that you're looking at. And then you can also download, as you can see, download the latest whatever. So if you want to download the latest 5 or 10 measurement of a track, it'll do that. and then you can do the massaging and stuff. And then in this particular window, you can see Upload to Maxwell. You can click that. It'll upload the result, smooth blended, into Maxwell, and you can use that as a color aim on the Maxwell side. That's all your carefully massaged data and that sort of stuff. What RIP output formats are available in Curve4? There are a lot. We've added some more. There's a combination of the control points and then, of course, the file format. But those are the file formats that we're exporting, including TED. And we're lovers of the concept behind TED as far as the file format goes. That TED format, in fact, the next release will show the ISO standard number beside it, is an ISO standard. And so when you're thumping around and talking to vendors, ask them about TED. Tell them to support TED, because hopefully over time, the RIP vendors could actually support a standard, and then we don't need all these plethora of different flavors of text files to send out. Now, the idea behind the references is it allows you to sort of bundle together these preferences into something that's kind of locked down. And so it's easier to use day to day to day. You don't have to set up a bunch of little parameters. But when it came to doing the custom color aim, so you've got your in-shop standard, you've got something you've just put through the blend tool, so you're really happy it's a great data set, you want to use it as a color aim. We wanted to make sure that it was in fact G7 compliant before you used it. So that's why we used that kind of special path. You go into verify, you bring the data in, then you can save it out as a custom color aim, and then you can use it. One thing I did want to mention is that the measurement function supports target definitions from multiple manufacturers. So if you've created your target in Measure Tool, ColorPort, I1 Profiler, or Barbieri's chart generator, you can bring those in to Curve. So you just drop it in the right folder, and Curve will allow you to use it to measure, even across instruments. So the FD-9, for instance, and also these table instruments like the LFP, I can take a Barbieri target and put it on there, or I can take an ISIS target and put it on there. The only one that's really picky about that is the ISIS itself, because when scanning with the ISIS, you need to have the right target dimensions and the bar size and all that sort of stuff. So scanning on the ISIS, you need a target definition file that really was created for the ISIS. But otherwise, you can mix and match a lot of different stuff. If you can fit the target inside the instrument, basically, chances are pretty good we will read in that target definition file and allow you to measure it. We're working on building, the most flexible and friendly measurement function that we can. And so we also welcome as much feedback as you are willing to give on this. Each of these versions of Curve, as well as our other software, under the application menu, there's a feedback area. You can also right-click, like if you're having problems with a verification file or a calibration or something, right-click on it and say Submit to Feedback, and it'll open up a new feedback item with that thing attached. And then you can ask a question or report a problem or make a request. Also, when it comes to RIP files, so if we're not supporting a file for your favorite RIP, but you have an example file, by all means submit that. If we can figure out what's going on inside there, we will add it to Curve. We're more than happy to add them. We haven't refused one yet, let me put it that way. So if you can send one, we're happy to add it. And if it makes your life easier, then we're happy to do so. Folders can be created for measurements by customer. Can subfolders be created? Yeah, you can create as many folders and subfolders in the file handler side of things as you want, and dig all the way down into them, drag stuff into them. It's really handy to be able to move files around, and you can see Don wasn't sure that he liked this feature, and I can see he's completely embraced it, which cracks me up. Now, in the view you see on the screen right now, you'll see there's a couple files there that say C3 to the right of them. That means those are Curve3 documents. So it will happily open a Curve3 document, but it will not allow you to save over top of it. You can put your existing Curve3 docs in there and folder organize them as whatever as you want, and you'll see which one are Curve3. It'll let you make modifications, and then when you want to save, it'll say, yeah, I got to save in another file. Do you want to do that? Yeah, and it'll save it. And you can see Don probably did that with that C3 session, because there's now one without C3 beside it, which means it's a Curve3 doc. So as you can tell, we put a lot of work into this version of Curve. We think that we've organized the tools into a useful set of functions, and especially proud of adding the measurement capabilities as well as all the nifty bits to the Calibrate function. But the Verify tool with an i1 Pro, I think, could be a very handy leave behind for customers who want to verify their G7 compliance periodically. And if you add an I/O to that, so that the i1 Pro is moved automatically for you, that plus the memory scan functionality will make it so that it's easy to do verifications over and over again. Save yourself some i1 Pro miles in your elbow. If you have additional questions, by all means, send us emails. You can email me at upton@chromix.com. You can email Don at hutchcolor.com. You can email Rick for sales questions at hatmaker or rick@chromix.com. Thank you very much. There's a lot more information on our website. You can download the app at any time and just click the demo button and poke around inside it if you like as well. Thank you very much, everyone, for attending. We really appreciate it.
Thanks a lot, folks. Cheers.